Okay, we're going to run through ray diagrams for lenses. They're similar to the diagrams for mirrors that we did the other day in class, but there are some important differences, which is why we need to make sure we pay attention to this. For the sake of this, I will do, as you can see here, I will do the parallel ray first. I'll do it in red. The central or chief ray will be in green, and the focal ray will be in blue. And our goal is to get the three rays to meet up somewhere, whether we have to trace it back or follow it all the way through. So let's see how this works. For this one, we're doing a situation where the object is farther away than twice the focal length, so out here in this region. So like mirrors, converging mirrors, breaking this into three regions. Out here, in between here, and closer to the focal length. And just like converging mirrors, which are of course convex, this is a converging lens, which is, sorry, I take that back. Converging mirror is concave. There we go. And here we have a converging lens, which does happen to be convex. But the converging point is that any light that comes in, say, parallel to the axis, will be bent towards the focal point. In fact, any light will always be bent in such a way as to be bent towards the optical axis on the other side. So, we'll start with the parallel ray. And it, of course, comes in parallel. Now, we do our bending for a lens right at the center point of the lens when we do a diagram. All we need to do is just run it right to the center point and bend from there. So, at that point then, parallel ray comes in parallel and goes out through the focus. So, something like this. In this way, and through the focal point. Then central ray or chief ray. Now, in the mirror, it bounces straight back where it came from. Here, was one of the differences from mirrors is that the chief ray is very simple. It just goes from the tip of the object through the center of the lens, where the center part of the lens crosses the optical axis, and just keeps on going, undeflected. Fix that a little bit. And so this is where we sort of cheat a little bit here. We kind of know where we want to meet. So when I do this last ray, the focal ray, I note where they're meeting, and I slide over to that point horizontally, and that's my target. So hopefully when I draw a line, the focal ray should go from the tip of the object through the focal point. I'm kind of also keeping in mind that I'm going to shoot for this point. So the focal ray comes into the focus, strikes the mirror, the lens I mean, there we go, and then comes out parallel. I think a little bit of adjustment. Got that? There we go. And we'll see that all of them do meet, and that our image is going to be right here. And that our image is going to be, the characteristics will be, of course, let's see, it looks like it is certainly a real image. There we go. Real images for lenses are formed on the other side of the lens, because that's what lenses are made to do, is let the light go through. So this is a real image on the far side of the lens. It is inverted, and it is, its magnification I would describe as reduced, not enlarged. Okay, so let's move our object to between the focal length and but less than double the focal length, and we'll start the same process. We'll go parallel ray, comes in, I'm going to have to adjust that one, and then goes out through the focal point. And you know what, I think I'm going to want to extend this. Then the chief ray or central ray is going to go straight through the center of the lens undeflected. I can kind of see my target now. It's way out there to the right. So I'm going to find that spot real quickly and mark it here. Let's be just under that line. So I'm thinking somewhere right in here is my target. And then the focal ray is going to come in through the focal point, strike about there, come out parallel. I'll make some quick adjustments here. Oops. There we go. Not bad at all. It'll work. So we now have this is our image. And I would say, looking at it, this one over here is about 4 blocks tall. This one is more than that. And once again, I think it's real. Certainly, it's on the opposite side from the lens, which would indicate real, inverted, and enlarged. It's certainly longer than the original. Now we're going to bring this object all the way up close to the lens, inside the focal length. This is your classic magnifying glass. And the image for a magnifying glass will come out to be virtual. It appears to be, when you look at a magnifying glass, think about that, the thing that you're looking at, the image that you see, appears to be on the same side as the object. That is an indicator that this, for a lens, is a virtual image. So let's see how that works. And virtual images, as you remember from mirrors, probably going to involve some tracing back. So we'll have to be aware of that as we go through. So parallel ray, in parallel. That's kind of ugly. That works-ish. Good. And then, through the focal point, then the chief ray, start at the tip of the object, go through the center undeflected, and right away I notice those two are never going to meet on the right-hand side there. This one and this one are not going to meet there. So I need to trace them back to find out where they would have met in a kind of a hypothetical sense. So best I can, try to indicate this one traced back. Not too bad. And then do the same for the chief ray. About there. And so I see where they meet now is behind. On the same side as of the lens as the object, which is going to be a virtual image. I note about where they, in this area, where they would meet, so I go across horizontally. So that's kind of my target. In this next one, I go as if I came from this focal point. Alright, so you start to stretch the truth a little bit. Now, technically, I don't really draw this part of it. But I do, it is supposed to be as if it came from that focal point. Like I said, we're going to stretch that truth a little bit there to make it fit. And then it comes out parallel. As best as I can get it on this diagram. The scanner doesn't quite give me a chance to get it perfectly parallel, but we'll go with it. And then I trace that back. And they all meet back in that area. And that leaves me with an image that has the following characteristics. Let's see, it's definitely virtual and upright. and indicating this is a use as a magnifying glass, it does, however, appear larger than the original, so it is enlarged. And then, diverging lenses turn out to be very similar to diverging mirrors, except for their shape, of course, in the sense that it doesn't matter where you put the object, you always get the same image characteristics, and they're always going to be virtual and reduced and upright. So let's go through and let's put an object in here. So we'll put one just right back here. Work. And the parallel ray. Parallel. Now, diverging lens, we have a choice here. Are we going to go from here like that? Well, that wouldn't make sense for a diverging lens. That just made the light bend towards the optical axis. We are going to go in such a way so that we come as if we came from this focal point, like so. Even though we don't really, we're going to go like that. Light is going to be bent away from the optical axis. And we're going to work ahead here and note, I'm going to trace this back because something tells me we're going to have to. Alright. Chief ray is going to go through the center undeflected. That doesn't make a bit of difference one way or the other for diverging or not. So, in this case, we see that the place where they're crossing is right in here. So here's, once again, I look across, and this is kind of my target on the mirror. So this is probably the weirdest one out of the whole group, the focal ray. It's not going to go as if it's going to this focal point. It doesn't go through this focal point. It's going to head from the tip of the object to this focal point over here. But it's never going to make it to that focal point. It's going to head that way initially. So it's going to leave here, head as if it's going to there, but when it gets to the lens, it's going to be bent away from the normal, and therefore come out parallel to the optical axis. And if we trace that back, within reason, I know. There. Not bad. We can get them to cross in roughly the same spot. And we see that in this case, the image is going to have the following characteristics. It is going to be, let's see, virtual. It is going to be upright. And it is going to be reduced. And that wouldn't make a difference. Anywhere you put the object, your image is going to end up with those characteristics for a diverging lens. Alright, so in the next video, we're going to look at this problem. We're going to attack this one.